So just like when we had our quadratic functions in Unit 1, the radical functions have the same idea with this like h and k, moving your function left or right or up and down, just like your vertex moved left or right or up and down in Unit 1. So for radical functions, it has the form y equals a times the square root of x minus h plus k, or y equals a times the cubed root of x minus h plus k. So we don't need to necessarily follow these steps, but I do want to talk about what the h and the k does, just like it did for our quadratic functions. So the h and the k is what moves your graph left and right. So h is the horizontal shift, just like it was for parabolas, and just like it was for parabolas, what's on the inside is always opposite. So this is like on the inside of the radical, just like the h was on the inside of the parentheses. So it moves it left and right, but it's always going to be opposite. So the parent function starts with that point in the origin. So h is going to move this point here in the center left and right, however many units. So the k then is your vertical shift. And that moves your graph up and down, and it's just the same. So we don't necessarily need to use that to graph. It just gives us sort of a starting point. So if we look at number 5, I think I'm going to do, actually, let's do number 6 and 7. So let's do number 6 first. 1/2 y, or the square root of x minus 3 minus 1. So you guys can put this into your calculator. What I'm going to do, though, is just pick some values that I know are going to make perfect squares. So the first point we can choose is what we were just talking about. So from the origin, our first point, so that is not our first point, we are going to move right 3 and down 1. So right 3 and down 1 is our first point that we can plot without actually really doing any calculations. Now, if I plug in 4 minus 3 is 1. The square root of 1 is 1. Times 1/2 is 1/2. And 1/2 minus 1 is negative 1/2. So 4 negative 1/2. And then let's do 7. So 7 minus 3 is 4. Square root of 4 is 2. Times 1/2 is 1. And 1 minus 1 is 0. So 1, 2, 3, 4, 5, 6, 7. And it's right on that x-axis. So this one is really little, and that makes sense because when we did our example, 3 stretched our graph. So if you have an a that is smaller than 1, it should sort of compress or squish your graph. Now for the domain and range, it's starting at this point. So it's starting at positive 3 for the domain and then going to the right. So our domain will start at 3 with a bracket because it's included and go to positive infinity. The range is going to start at the y value of this point, and it's going to go up. Slowly it goes up, but it still goes up. So our range is going to be negative 1 to positive infinity. Now the domain will always be from that point to the right. It should never be going backwards at all, but when your function flips, sometimes your graph will be going down instead of up. So when that's the case, if that were your example, the range would actually start at negative infinity and go to whatever your point was. So, and that will actually be what happens in number 4. Because remember, range is from lowest to highest, bottom to top, because it's the vertical direction. So let's look at number 7. Cubed root of x plus, or negative cubed root x plus 2 minus 3. So again, I'm just going to plot my first point. So from the origin, the first point that we're going to have is going to be 2 units left of the origin and then 3 units down. So negative 2, negative 3, that will be my first point that I can sort of plot without doing any math there. Opposite, same. And then I'm just going to pick some other points here. So I'm just going to do 6 and negative 10 to get some negatives and positives because of the cube root. We can do that. So if we do 6, 6 plus 2 is 8. Cube root of 8 is 2. So we've got negative 2 and negative 3. That gives us negative 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then negative 10 plus 2 gives us negative 8. So the cube root of that would be negative 2 times that negative gives us positive 2. So positive 2 and negative 3 is negative 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1. And then get it that it looks like a straight line, but you guys need to understand that it is not a straight line. So don't draw this on your test or your midterm or whatever, wherever it might be. Draw it so that it's curved. I need to understand that you guys understand that it's not a straight line. So, domain, I don't even need to try to figure out because it was a cubed root. The domain will be negative to positive infinity, and so will your range. There's no stopping point. It continues forever in the vertical direction and the horizontal. So try the last two, 4 and 5.